Hello again. So this is part two video of the heat map generation in QGIS. So the video recorder that I'm using only allows me to record a video for 15 minutes. So I apologize for that. I'm trying to get a more sophisticated, more advanced screen recorder. So until then, you'll have to bear with me because I can't really record video more than 15 minutes, which is why I also have the part 2 of the video. So this video is a continuation from where we last left off. So in the last video, that is the part 1 video of the heat map generation, we had assigned weights to the data point, and when generating the heat map, we sort of instructed QGIS to weight points by the weight we assign to the crime type. So I use the color ramp of a yellow to red, but you can use like any other color ramp that you want. You can play around it, but for now I'm just leaving it to yellow to red over here. So now this is a very simple, a little more than a simple heat map, I would say. And there is also another processing tool in QGIS that allows us to create a more sophisticated heat map, and that's called the kernel density generation. So what QGIS does is it has an inbuilt tool called kernel density generation tool, which uses the kernel density algorithm to generate the heat map. So let's go ahead and do that, but before that we need to project our data to a different projected coordinate system. So right now our CSV file is in the geographic coordinate system, and to use the kernel density algorithm, we would need to have our data in the projected coordinate system. The projected coordinate system can be UTM, so UTM, and I think there is also another one that's called British grid, something like that. And so the difference between geographic coordinate system and projected coordinate system is that the geographic coordinate systems are based on spheroid, and it utilizes the degrees or the angular unit to assign any location on Earth, while the projected coordinate system are based on a plane that is the spheroid is or the Earth is projected on a 2D surface, and it utilizes linear units like feet, meters, and etc. And because we have the location data in the CSV file in latitude and longitude, we need to sort of project our layer into the projected coordinate system. If this was in if this was already in like feet or meters meters unit, then we need not project our layer to the projected coordinate system. But because this is in latitude and longitude, we need to project our data to the projected coordinates projected coordinate system. So to do that, what we will do is we will click on processing, the toolbox, and I will search for reproject layer. I'm going to click on this. You should get this dialog box, and 2019-07 Kent Street. I'm going to look for British National Grid. There are many other projected coordinate systems. The one that I can remember on top of my head is the UTM. You can look more for other coordinate system that is projected coordinate system, but because this is the London data set, I'm using the British National Grid. I'm going to hit on OK, and I'm going to click the run. Okay, so now I will so if you are following with me in creating this heat map using this array data set that I provided to you last week, then you should also see something very similar in your screen. So what I'm going to do is I'm going to uncheck the 2019-07 Kent Street. And now with this in place, what I'm going to do is I'm going to look for heat map. Okay, you can just look for heat map. Okay, kernel density estimation. So the kernel density estimation is an algorithm that is used to determine how the influence of a point should be spread out over a given radius. So it is basically used to calculate the buffer area around a data point. So once I have this heat map kernel density estimation dialog box open, okay, so the point layer, the layer which we are going to use to generate the heat map, is going to be the reprojected layer. You can rename this any way you want. I have left it to the default name, that is reprojected. And radius again, I told you that it's the buffer area around each point that is used to calculate the density, or that is used to calculate how influential the data point, how that is used to calculate how to, how influential the point is, over a given radius. So because when we first started this video, we sort of assumed that when a crime happens or when a crime occurs, we would like to believe that it will sort of affect area that is within the 5 kilometer radius. So because the unit is in meters, 5 kilometer would be 5,000 meters, right? And the next variable over here is rows and columns. So these rows and columns are how large our output raster is going to be. The rows and columns are actually the number of pixels that is going to go into our map. So let's say I would like to have 500 rows. So that would mean there will be 500 pixels that will go that will be going from north to south. And as soon as I enter this value, and if I hit the tab, you will see that these values will automatically be updated. So this is this is something I think that makes our life easier, or let's say QGIS makes our life easier, meaning that as soon as we hit the row number, all other variables will also be updated automatically, making our life easier. So because I entered 500, so that this would mean that there will be 500 pixels going from north to south, and then 500 pixels going from west to east. So and just a quick FYI, so the output raster is going to be a pixel image created by QGIS just by looking at how dense the points are going to be around each pixel. So I have it over here. I would like the pixel size to be somewhere around like 50 maybe, and that will again update the number of rows. And you need not really worry about much of this field, so because like I said earlier, the other fields are going to be updated as soon as make changes to one of the fields. So I'll scroll down. Wait from the field. You can leave this field is optional, but because I want to I want to pinpoint the area which has higher concentration of violent related crimes, which is why I created the weight variable. I would like the new heat map that will be generated using the kernel density estimation. Use the weight, the new variable that we created. The other option here is kernel shape. Kernel shapes are a bit complicated, but it defines how large the number is, that is how close a data point is to the point within the buffer area. So the quartic kernel shape is the default kernel shape of QGIS, There are also other kernel shapes available, like in triangular, uniform, tri-weight, and others. So if you choose uniform, then every space within that buffer is treated the same way or equally. And if you choose quartic, it drops off, pretty steeply, so that pixels closer to the points, that in our case closer to the crime data point, will have much higher number, and it drops off as you get out to the edge of the buffer. So I will leave it to the default setting, and I will just hit run. This may take a while, so I'm going to pause the video for a while to save our time so that I don't have to create a third video. I will be back as soon as this gets completed. This is going to take like in 2 to 3 minutes, so I'll see you in a bit. So my algorithm has finished running, so I'm going to close it. Okay. So right now it does not look so attractive, and this is because we are on a single band gray. What we can do is we can go to pseudo color range, and we can choose darken. Okay. Uncheck this button over here, projected layer, and we can play around the tool over here in the rendering mode. Okay, I'm gonna zoom in. Okay, so you can play a bit around this. Okay, I'm liking the color. Okay, so I think I like this one better. Okay, so here we have the final heat map that we wanted to create for today's video. So over here what you can see is there is this area. This area over here has higher concentration of violent related crimes, followed by there are also crimes that are spread out in the other area but not so much. So using the legend over here, we can say that the area with the least concentration of crime will have like a very pale yellow color, and the area with the higher concentration of crime will have more reddish structure. So the other thing that I wanted to mention is there is a bit of so this is the legend of the heat map that we have implemented in our image over here. So the values over here is not that very helpful because there is a bit of maths going on here when the heat map was being calculated. So in the legend that we'll be creating for this one, we will just be showing the gradient from least to most dense instead of like most dense. So that is that. And over here I can also choose like the mean and max value. So over here I have like the exponential values. That is, when the heat map generated, each of these data points will have certain heat map band value that got generated when we use the kernel density algorithm. So I can say that show me the data points which has the band value that is at least 0 to you can set this to like 5,000 or anything that you want, but I'm going to leave it to default. Let's say if I put it like 5,000, that's going to be something like this. Let's go for 15. Okay, so this is going to show me the heat map that will have the band value of at least like 15,000 or something. Yeah. So okay, so this is this. In the next video I will show you how to import it to an image with the legend. with the legends.